Hello friends, today we'll see composition of functions. Before moving into the definitions and the problem, you should understand what is the concept of composition of function. Let me explain to you clearly by example. The example what I've taken is class 12 students appearing for board exams. Uh, what is the important thing? If you have to attend a board exam, you should have a hall ticket wherein they will give you some number, hall ticket number, which will be the roll number, so that you need not write your name. The number will be assigned to each student. So each student will be having a particular roll number. So that is assigned by the examination board. That is a number which will be different for each of the student. None of the two students will have same roll numbers. Once the exam is over, for evaluation, while before sending to evaluation, in order to have confidentiality, the board again assigns a fake code number. Some number say 1020, which is a fake code number. So which is nothing but a number which is just used for confidentiality purpose, so that nobody can reveal the results unofficially. So this number, whatever has given of the roll number, for that particular number, each and every particular roll number, a code generate, for a code number will be generated. And finally, when the results have to be announced, then these code numbers will be again fed back to their respective roll numbers, so that the result can be accessed by using the roll numbers. So here you can see there are two functions. One is function A to B, that is nothing but A is the student name. For each student a roll number will be assigned, that is B is the roll number. And the second function is, for once the roll number is assigned, for each roll number a code number is generated. So this is how composition of function. That means, how can I represent these two functions? I can represent it as G of F. Why I am writing, see, in this case F is the first function, that is assignment of roll numbers to each student, and G is the assigning of code numbers to each roll numbers. So always remember, you need to represent a composition of function whenever you have two function F and G. Composition of function F and G is given by G of F. Why? Because so G of F of X will happen. What is f of x? Assigning of roll numbers to each student. So first task what has to be done is roll number assignment. Once that is assigned, then only you can assign the code numbers. Before, first only initially if you write f of g, so that means if you write like this, f of g, that is nothing but f of g of x. That means you need to assign the code number, which is not possible because code number is assigned to each of the roll numbers. So don't always remember, for second function is represented first, followed by the first function. Now in this case, first roll number will be assigned, then again G of, that means for this roll number code number will be generated. So I hope you have understood what is composition of function. Now let's move on to the definition. Same definition, it is like this. Suppose see here, f and g are the two functions where f is related from a to b. As you can see this figure, f is from a to b, which is nothing but a will be the students, number of students. So suppose if there are 50 students, according, so each student will be picked his name, and for that name they will be assigning the roll numbers. Once the roll number is assigned, then comes the second function, which is from b to c. This is assigning of code numbers to each of the roll numbers. So therefore you can get the composition of f and g denoted by g of f, which is defined as function g of f, which is nothing but direct relation, that is a to c. If you want to relate a to c, it is nothing but you need to write it as g of f, which is nothing but g of f of x. You have two functions, so first roll number and then you need to assign the code number. So this is how it is represented. I hope you are clear with this definition and the diagram. The diagram tells you the clear, gives you the clear picture of what do you mean by composition of function. So now let's take an example of how to find the composition of a function. In this case, they have given two functions f and g. They have given how it is mapped. Then they've given the value, what is f of 2, which is equal to 3, f of 3 is 4. Like that. Similarly, they have given for g of 3, g of 4, and g of 5, and g of 9. So let's draw an arrow diagram for each of the function. Since they have given the elements which is related 2, 4, 5, 3, 4, 5, 9. F of 2 is 3, f of 3 is 4, f of 4 is 5, f of 5 is 5. So this is function f. Now let's take function g. That is 3, 4, 5, 9, 7, 11, 15. So in this case, g of 3 is 7, g of 4 is also 7, g of 5 is 11, g of 9 is 11. So how can you find g of f? You need to find for each and every value of x. You know what is g of f? It is nothing but g of f of x. So you have a set of values of f, that is x. So you can just find out first one. If it is g of f of 2, you know what is f of 2? That is equal to 3. So write 3. G of 3. What is g of 3? Which is nothing but, which is 7. Which is equal to 7. Similarly, you can find it for other values of x. F of 3 is 4. So it becomes g of 4. G of 4 is again 7. Similarly, g of f of 4, which is equal to f of 4 is 5. So it will be g of 5, which is equal to 11. G of f of 5 is equal to g of f of 5 is again 5. G of 5 is equal to 11. So this is how you find out the composition of function. I hope you're clear. And one more thing you need to remember, you cannot just simply write g of f is equal to f of g. No, this will not be equal. Okay, so for let's take an example. In this case, so find g of f and f of g if f is a function in which r is related to r and g is a function. There are two, these are the two functions where f of x is given by f of x is cos x and g of x is 3x square. Okay, then I can tell that g of f of x is equal to g of f of x, which is nothing but g of, what is f of x? It is cos x. What is g of cos x? G is 3x square. So wherever x, you need to substitute it as 3x square. So this will be the first one. If I want to find f of g of x, which is nothing but f of g of x. What is g of x? It is 3x square. What is f? F is cos x. So wherever x, substitute cos x. So 3 into cos square x or cos x the whole square. So this is second one. Now by looking at this only, you can say that it is not equal. If you want to be more clear, you can just take an example. Say when x is equal to 0, you can write cos of 3x square. When you substitute it 0, it will be cos 0, which is equal to 1. when x is equal to 0 in the second f of g, you can, this is g of f, which is equal to cos 3x square, and f of g is 3 cos square x, which is equal to 3 cos square 0, which is nothing but 3 into 1, that is 3. Therefore you can say that g of f is not equal to f of g. I hope you are clear. Invertible function. What do you mean by invertible function? An invertible function f, where here you can see f is related, like between x is related to y, is a function, is defined to be invertible if there exists a function g which is related like this. If see in the first function f, which is related from x to y, and here, if there is existing a function which is related from y to x, such that g of f, when you find out the composition g of f, it should be ix, that is nothing but the value of x, and f of g is nothing but iy. Then the function g is called inverse of f, and it is denoted by f inverse. So this condition has to be met. So then only it is said that g is this function, that is y to x, that is inverted function is existing. So this is how you need to check whether it is invertible. To check whether it is invertible, the condition what it has to meet is, if f is a invertible, then f must be a one-to-one and onto function. I think you all know what is one-to-one and onto function. So if it is an invertible function, then you should know that it will be an one-to-one and onto function. Or conversely, you can say if f is one-to-one and onto function, then f must be invertible. So if you know, if the relation is given, you can just draw an arrow diagram and check whether it is one-to-one and onto function, or you can just check out the values. If you come to know that if it is one-to-one and onto, then don't find the function, then don't do the actual calculation. By this only you can say that it is invertible. So you need not find out the inverse. I hope you are clear.